Today we're going to talk about digital output. All right, so what does that mean? Let's talk about it. So digital output is our topic for today. Digital, it means a lot of different things in different contexts, but in this context, it means that it is a number that is either 0 or 1. And we actually have different names for this same concept. So first of all, for example, 0, we might also think of that value as being false. We might also think of it as being off, like when we light up an LED or turn it off, we would say the LED is off. LED is off. It has a value of 0. We can think of it as representing false. We can think of it as low, a low value, and what we're really talking about is the voltage. And finally, we can think about it as being 0 volts, or if you prefer, ground. Similarly, 1 can represent true. We can think of it as being true, and you guessed it, on, and instead of low, high. And when we mean high, it's high voltage. And for the Pico, that value happens to be 3.3 volts. Other microcontrollers use 5 volts, but the very common values are 5 and 3.3 volts. All right, so that's what digital means. Now, how about output? Output is from the perspective of the microcontroller. So the microcontroller here, it can actually put out a value, and this is on its pins. Remember that the pins is the only way that the microcontroller communicates with the outside world. So if the microcontroller puts out a value of high, or however you want to think of it, on one of its pins, that would be called output. Input, which we'll get to later, is when it actually reads a value that comes from the external world. It reads a value on one of its pins, so we can send information out and in. But again, output is from the perspective of the microcontroller. So that is what digital output means. Now, let's go ahead and actually create a circuit that uses this, and this should be a little bit familiar. So the first thing I'm going to do, we're actually going to do our LED circuit, and we're going to do things that are a little bit more interesting for our program. So again, whenever you use, whenever you're building a circuit, I recommend that you go ahead and draw it. And it's going to look like this. It's going to be resistor. I'm going to make my resistor 330 ohms as usual. And an LED. And then back to ground. Okay, so that's our circuit. And now I'm going to go ahead and put this together. And the first thing that the first issue we have is, okay, where is pin 9? Pin 9 is GP9. You might remember that it is not obvious by looking at the top of the Pico which is pin 9. So we use this little sheet here and we say, okay, where is pin 9? And they are labeled GP9 on this diagram, and GP stands for general purpose. General purpose means they can be used both for input and for output and other special things. They can do other types of things as well. All right, so GP9. Now, GP9, if we want to know where on our breadboard we should plug in our jumper, we notice that it is actually labeled 12. So this label in the middle here is the row on the breadboard. And this is the left side. This is the right side. So GP9 is 12 on the left side. So I'm going to go ahead and I'm going to use my jumper. Blue jumper because it's neither positive nor negative. It can be actually either. And then I'm going to go and take it down here somewhere. Doesn't matter where. I'm going to plug in my resistor. Make sure that one of the legs of the resistor is in the same row as the jumper. And then the other, I'm going to bring in my LED. and it will go the other end of the resistor. Make sure that's the long leg because it will be the closest to the pin that's actually going to go high and light up the LED. All right, so I'm going to go ahead and put this in here. And then finally, I need to complete my circuit and go back to ground. Where is ground? Well, here's one right here, 18 on the right-hand side. So I'm going to go ahead and use a black jumper representing ground. Electricity doesn't care the color. We humans do. All right, so I'm going to put it in here, and now I have my circuit. This should actually be an implementation of that circuit diagram. Okay, let's go ahead and write our code. So as I said, well, first I got to do file, new, and here's my new file. And I'm going to remember imports come first. From machine import pin, because the pin, this library has things like pin, which actually allows us to program pins. Make sure, by the way, that all of this, the capitalization is exactly this way. Like most programming languages, Python is sensitive to capitals. If you capitalize it, it does not know what you're talking about. I happen to know that we're going to need our little sleep function, so from time import sleep. And now the second thing that you do in your programs is you identify the pins that you're going to use and how you're going to use them. So I'm going to use pin 9, GP9, and I have to say that it's going to be pin.out. So this means that this is digital out. All right, now I could light this up. So you might remember that previously we did just LED.on, and that works great. But today we're going to do something a little bit different. Oftentimes you want your microcontroller to run a program continuously. So for example, you might have something that's monitoring people approaching the front of your house. You might have something that waits for a button to be pressed. So there's 1,000 examples, but sometimes you just want the program to continue to run. So one way to do this is by using something called a while loop. So if I write while true, then what this means is I'm going to give, immediately after this, I'm going to give a whole sequence of commands, and they will continue to execute and loop over and over again forever or until the Pico is turned off. Now, make sure that this syntax is exactly right. Notice true is capitalized. Notice that there's a colon. Another thing you might have noticed is when I hit return, it automatically indented. And indentation is a key part of the Python programming language. The way that we tell what is inside the loop, any loop actually, is that all the statements immediately following the while true but indented are part of the loop. So if I wanted to turn on the LED in my loop, then I would do it this way. And now we remember that we need to put in a little bit of a sleep, or we will not be able to see the LED if we turn it off afterwards. So I'm going to do this. So I'm going to turn it on. I'm going to sleep a half a second and then turn it back off. Now, if I were to do this, then you would be disappointed because it would turn it on, it would sleep half a second, and then it would turn off, but then it would immediately loop back and repeat the statement. So we need another sleep after our off. Sleep 0.5. All right, so this is an entire program, and again, the while true will execute all of these 4 statements over and over and over again. It knows that that's what I want because these are all indented. So I'm going to go ahead and save this, and I'm going to save it to the Pico, and I'm going to call this blink.py because it's going to make that LED blink if things work correctly. Okay, so if we have done everything right, then when I run this, this light should blink every half a second. Okay, let's see if that works. And sure enough, it does. So great practice would be, by the way, if you notice if I hit the stop command, that's the only way it's really going to stop other than turning it off. It looks a little bit ugly, but that's perfectly normal behavior. All right, so you can experiment with this. For example, you can actually change these values. So 0.1 is going to be a tenth of a second. If I save this and then run it again, you'll see that it's blinking much faster. You can have these be different values and so on. You can actually, another thing to think about is, what if I wanted a second LED to blink? Well, I could actually create a second, I could wire up a second circuit with another LED, and I could give it another name and turn it on and off in exactly the same way. So feel free to experiment with this.